Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, our present module is module 2, where we will discuss the different types of fibers, different yarns and fabric constructions for human protection. So, for protective textiles we need specialty fibers, specialty yarns and specialty fabric construction. But it is not that normal commodity fibers are not being used. Even normal fibers like cotton, silk, wool are used in protective textiles, but different applications. So, we will discuss the possibility of all the fibers and their characteristics and how they are applied in the construction of human protective textiles. So, these textile fibers used in human protection are basically the textile fibers used in the manufacture of protective textiles, which are designed to safeguard the wearer from various hazards like extreme heat, extreme cold, mechanical injury, chemical exposure, biological agent and ballistic threats. So, this basically for textile material, these are the fiber, different fibers which are used for the protection of the human being. The features of fibers used for human protection, the fibers should be having high tensile strength and they should be degradable. They should be durable, because if the fibers are degradable, then they will not perform in long time. They should be resistant to heat, flame, chemicals, ultraviolet rays and microorganism. The fibers should be able to absorb and deflect mechanical energy like bullet or blast impact. The fibers should be lightweight and comfortable handle for ease in protective clothing. The barrier properties against dust, fluid and different biohazards in medical applications, that the fiber should be able to perform all these activities. The commonly used fibers for human protection are aramid fiber. Aramid fiber is used widely in protective textile like meta-aramid, para-aramid. They are used basically bulletproof vest, flame resistant textile, industrial protective gear. Then ultra high modulus polyethylene, mainly used for bulletproof vest, ballistic protective equipments. Glass fiber, they are due to their high heat resistance. So, for heat protective textiles like insulation material that we can use, and for even for composite for high strength we can also use the glass fiber, polypropylene like aviation, spacecraft, industrial protective fabric. So, that we can use polypropylene. Carbon fiber we can use for medical nonwoven protective material, filtration, marine textiles. PBI for high temperature protective textile, tensile fiber for medical textiles, industrial protection, cotton sometimes used for medical protective fabrics after antimicrobial treatment, and carbon fibers are used for different types of high strength use. Now, if you see the historical development for protective clothing, so there are different types of fibers are being used. So, wool fiber, silk, mohair, cashmere, okay, these are the fibers. Early beginning natural materials are only used. Okay. So, animal hides, leather, fur, plant fibers like your cotton, they are used for protection against the cold, rain and injuries. Protection in warfare, advance to metallic armor, different types of layered garments made from the linen or wool are being used in earlier days for warfare. These fabrics actually earlier material they offer both flexibility and resistance to weapon. So, if we use the multi-layer linen or wool fabric, so that we used to give some protection. So, silk and the first textile innovation, the spider silk made body armor was used to protection, as for example, the against arrow, low velocity projectile. So, that silk made fabric for protecting against the arrow. Spider silk was valued for its tensile strength and flexibility. So, those were used in early days. Then comes the artificial silk, that is rayon is being used for in the industrial era. In the initially the rise of manufactured fibers were there, high performance fiber in 19th century, that artificial silk was invented, and that those fibers were used for protective garments. Artificial fibers found a role in the diverse technical and protective applications. Like in parachute, rope and military apparel. Then synthetic fibers came. So, nylon was invented in 1930 and was extensively used for different applications like military apparel, parachute, ropes were used during World War II. Nylon and other polyamide were commonly used for parachute, rope and military apparel. Next comes industrial era, rise the manufacture of synthetic fiber, revolution, that polyester, acrylic and polypropylene was emerged, okay, and offering better durability, resistance to chemical. So, these fibers were used for human protection, adaptability to for industrial and protective applications. We can see the automotive, technical textiles, healthcare, okay, different applications were there. So, in industrial era, the rise of manufactured fiber, high performance fibers were there. That now there are high performance fibers has started in industrial era. The aramid fibers came, these are the vital for bulletproof vest, firefighter suit, industrial protective gears. Now, the advanced polymer like PBI, PBO, ultra high molecular weight polyethylene has improved the fire resistance, chemical resistance and impact protection. So, this type of fibers have come up for protective textiles. They are applicable in different types of application, the fireproof clothing, body armor, then modern era advanced and smart fibers are there, microfibers, low cell fibers invented as a finer than the silk, enhance comfort, performance in PPE and medical use. So, microfibers are used for many protective textiles. Smart fibers are developed inspired by spider silk. These are being developed to self heal, adapt to environment and detect contaminants. The modern era fibers actually unite the sustainability, performance with recyclable polymer, antibacterial treatment and customized properties for clothing filtration and extreme environment. So, the modern era fibers are developed. So, let us see the scope of textile fibers in human protection. So, types of protection. So, you can see protection from fire, extreme heat, extreme cold. We need fibers for this type of protection. We need fibers for protection against hazardous chemical, biological agents, pathogens, nuclear reactions. We need specialized fiber for protecting from the physical injuries such as cut, abrasion, bullet, blast. So, that is ballistic protection. We need specialized fiber for to safeguard us from UV radiation, wind, rain, dust, foul weather. So, the application area you can see, if you see the application area is enormous for protective textiles. So, protection against ballistic threat, chemical, biological agent, harsh weather, which requires lightweight, durable, multifunctional textiles. Healthcare products such as mask, gowns and drapes to prevent infection and pathogen transmission, especially highlighted during COVID-19. We can see during COVID-19 we need different types of gowns, masks, PPE kit with actually multifunctional characteristics. Protective clothing reduces risk from chemical, heat, dust and mechanical hazard in industries like construction, mining and chemical processing. So, these are the different areas we can use the specialty fibers. So, firefighter, emergency response and workers in hazardous environment use protective textile for safety. So, these are different scopes for protective different sectors where these protective textiles are used. So, the importance are that the fibers, textile fibers prevent injury, illness and fatality caused by occupational and environmental hazard. So, we should select fiber judicially. Modern protective textile balance safety with the wearer comfort to ensure consistent use of the effect and effectiveness. Okay. Development of multifunctional, lightweight and durable fiber enhance the protection without compromising the mobility. So, that we can develop. Especially critical and medical fibers, okay, that is to reduce infection spread and enhance the public health safety. By providing injuries and health issues, protective fibers reduces health cost, that is during the healthcare cost, improve productivity and safeguarding workforce well-being. So, this type of fibers are very much required for the society. Commonly used textile fiber structure for protective application. Different fiber structures are used: high performance filament, staple fiber, that is in short form, multifilament or textured fiber, coat sheath structure of fiber, micro and nano fiber. So, we can use the protective produce protective textile from the filamentian, single filamentian, monofilament or staple fiber yarn. You can use the multifilament yarn or textured filament depending on the application, and in some cases we can use the coat sheath structure. So, that we will discuss in detail, and micro and nano fibers. These are the fiber structure, commonly used fiber structure for protective textiles. Now, high performance filaments, if you see, high performance filaments are engineered materials with exceptional mechanical and thermal properties. So, they used in demanding applications requirement where strength, durability and resistance to extreme condition is required. There, in those cases we use the high performance filament yarn. What are the characteristics here? It has got high tensile strength, excellent modulus, very high stiffness, low density, resistance to heat, chemical and abrasion, long term durability. So, due to its filament structure, long filament structure, so durability is high. So, the classification, if you see, the high performance filament fibers classified based on source material. What are the source materials? Synthetic organic high performance filament. This is the one classification where aramid fibers are there, polyamide fibers are there, ultra high molecular weight polyethylene fibers are there. So, synthetic origin high performance filament, then synthetic organic fiber, these are the materials. So, organic origin is aramid, polyamide and ultra high molecular weight polyethylene, and its inorganic origin fiber, that synthetic inorganic fiber, it is carbon fiber, ceramic fiber, these are the inorganic fiber in the filament form we get. Now, first let us discuss the aramid fiber. So, aramid fiber is basically of two types, one is meta-aramid, another is para-aramid. So, this is the typical structure of aramid fiber. It is manufactured fiber in which the fiber forming substance is a long chain synthetic polyamide, in which at least 85% are amide, and that means CONH group linked. This amide links are attached directly to two aromatic ring. So, that is one amide is linkage are amide linkage are attached to the two two aromatic ring. So, you can see here, this is the typical molecular structure. So, aramid fibers are synthetic polymer, organic, with repeated phenyl ring linked by aramid group. Aramid group CONH form strong bond that are resist to solvent and heat. So, that is why this aramid fibers are highly heat resistant, and they are also they does not dissolve with a normal solvent. Phenyl rings are bulky 6-sided group of carbon and hydrogen atoms that prevent polymer chain from rotating, twisting around their chemical bonds. So, they are very rigid structure. Now, these are the structural characteristics. Now, let us come to the chemical characteristics of aramid fiber. All aramid and fibers have hydrophilic amide link, but moisture absorption varies by product. The PPDT fibers resist most salts, but loses strength in strong acid. This is the characteristics, chemical characteristics. Aramid fibers are difficult to dye due to their high Tg. So, normally they are not that, they can be dope dyed also, or maybe at high temperature it is although difficult, but we can dye it is not that we cannot dye. The aromatic structure of para-aramid cause UV or oxidation leading to discoloration and deterioration in strength. So, para-aramid is actually it gets UV oxidation. So, as far as thermal characteristics is concerned, para-aramid does not melt, but decomposes and burn with difficulty due to low oxygen index. Some aramid retains 50% strength even at 300 degree Celsius. So, that is important. So, at even at prolonged 300 degree Celsius, it retains some strength, 50% strength. Aramid fibers show a high crystallinity, which results in negligible shrinkage at high temperature. So, that is one advantage. That is why the metaramid is used for fire protective garment with less shrinkage. The mechanical characteristics, the aramid yarn have high tenacity, 5 times stronger than silk and 2 times stronger than glass fiber or nylon. Aromatic amide groups and high crystallinity give high strength, retains up to 300 degree Celsius. It is elastic in tension, but show plastic deformation under severe bending. So, that in tensile load, if we use, it is elastic in nature due to the molecular orientation, it is elastic, but it is plastic deformation is there when we it is under severe bending. If you see the applications of aramid fiber, ballistic protection, helmet, body armor, vehicle armor. So, that where the impact strength is important, there the aramid fibers are used. Cut resistant gloves, protective clothing. So, we can use the aramid fiber, and for meta-aramid we can use for firefighter suit, thermal protective gear, okay. And for ballistic protection, para-aramid we can use. So, aerospace, automotive composites, we can use this aramid fiber for making composite. Ropes, cable and reinforcing material we can use. Filtration and insulation fabric, some we can use this sports equipment, okay. Sail protective gears, there where the strength is required. So, we can use the aramid fiber. Next fiber is polyamide. Polyamide fibers are synthetic fibers made from polymer containing repeated amide group, CONH group, commonly known as nylon. So, nylon 6 or nylon 66 first developed by Carothers in 1935. Nylon 6 and 66 were first commercial polyamide fiber. The structural characteristics we can see here, the Molecular structure consists of repeated unit of amide CONH group, linear polymer chain that can form hydrogen bonds between the chain. These chains are created through condensation polymers. So, it is created during the using the two chemicals using the condensation polymerization, often from diamines and dicarboxyl acid. The structural characteristics of polyamide fibers are their the crystallinity is that their polyamide fibers exhibits high crystallinity. The crystalline region alternate with the amorphous region. The orientation is polymer chains align along the fiber axis, they are oriented. Orientation can be improved by stretching during manufacturing. So, if we increase the orientation, so their strength and will increase and it will be high strength polyamide fiber. Chemical characteristics of polyamide. Polyamide fibers have CONH chain that forms strong hydrogen bond, giving them the strength and resilience. Polyamide fibers like nylon 66 are damaged by strong acid, but resist dilute acetic and formic acid. So, if we have strong acid, then the fibers will be damaged, otherwise the light dilute acid, formic acid or acetic acid, it can resist. Most organic solvents do not affect polyamide fibers, but phenol, metacresol and concentrated formic acid can dissolve them. So, dilute acid is it can resist, but if we use the concentrated formic acid or any strong acid, that it will even phenol. So, this type of chemical it will actually dissolve, otherwise most of the organic solvent it does not affect. Polyamide fibers resist most bleaches, but can be damaged by strong chlorine and oxidizers. So, we must know all these characteristics for actual application in a protective performance. So, we should consider all this chemical nature. So, polyamide fibers resist microbe, moth and light discoloration, but lose strength with prolonged sunlight. So, we should not use the polyamide fibers for outdoor application, because that will lose its strength. So, we accordingly depending on the characteristics, we must select the application area. Now, thermal characteristics, if we see the most polyamide melt between 220 to 260. So, like nylon 6 its melting point is around 220 and nylon 66 it is around 260 degree Celsius. So, we must select the application based on the melting point also. Stable up to melting, but prolonged exposure above 160 to 210 degrees causes aging, brittleness and strength loss. So, high temperature application, for those application we do not use polyamide fiber, but normal environmental temperature these fibers are behave properly. Rapid degradation begins in at 220 to 250 degree Celsius, lowering when blended with the other fibers or additives. So, we can blend with other fibers to reduce the degradation. So, nylon 6 fiber typically have a glass transition temperature around 50 to 60 degree Celsius. So, above that the molecular mobility will start. So, polyamide work between minus 30 degree Celsius to 80 degree Celsius, but higher sustained heat shorten their service life. So, if we try to use the polyamide fiber consistently at maybe 100 degree Celsius or maybe around 80 degree Celsius. So, they will actually their service life will be reduced, burn slowly and may self extinguish once the flame is removed. So, they will not propagate the flame. Some aromatic polyamides show very low or negative thermal expansion, ensuring high dimensional stability. So, their thermal dimensional stability at high temperature is excellent. So, they can use they can be used at elevated temperature. And as far as mechanical strength is concerned, it is a high tensile strength and 80 to 120 megapascal for nylon 66 resisting strong pull. So, this can be used for different ropes and all applications where high strength is required. Elastic stretching and recovery to provide resilience. So, it shows some elastic characteristics, flexible and can be shaped without losing integrity. So, these fibers are flexible in nature, absorbs impact, enhance durability and toughness. So, basically the work of rupture of nylon is very good. So, that is why for different applications where impact absorption is important, there we can use the nylon fiber, nylon 6 or nylon 66, which enhance the toughness. High abrasion resistance ensures their durability under rubbing and scraping condition. So, for outer wear garment, outer wear where the high abrasion is there, that condition. So, we can use this type of fabric. Like common application is the in the shocks where high abrasion is always there. So, that for those applications we use nylon polyamide fiber, stretch 20 to 40% before breaks. So, its breaking strength is fairly good, showing good extensibility. The applications are there are wide applications of aramid fiber, ballistic protection, helmet, armor, vehicle. So, they are what basically due to its high strength. So, for ballistic protection we can use this polyamide fibers, cut resistant gloves and protective clothing we can use, firefighter suit and thermal protective gear. So, where in the inner layer we can use this polyamide where temperature is not does not go that high, because inner suit airspace application and automotive composites we can use the nylon 66, ropes, cables, reinforcement we can use filtration and insulation and sports equipment, shell, protective gear, all these applications where we can use the nylon. Now, the next fiber is ultra high molecular weight polyethylene, UHMWPE. So, in short people use UHMWPE. The structural characteristics of ultra high molecular weight polyethylene fiber is this is the polyethylene chain. Okay. Now, this fiber has long linear polyethylene chain with a molecular mass 2 to 6 million Daltons, very high molecular weight. This fiber is a linear semi-crystalline polymer made up of crystalline and amorphous phase. The crystallinity here it varies from 39 to 75%, boosts strength and abrasion resistance. This time molecules connect crystalline and amorphous region, enhancing toughness and impact strength. So, they basically they are highly tough material and it is impact resistant. It is highly linear structure with a few side chains, enable tight packing and strong van der Waals force. Basically that due to the absence of the side chain, they can be packed closely. So, that we can create a very high molecular weight and due to the strong van der Waals interaction. The chemical characteristics of ultra high molecular weight polyethylene fiber is that it is chemically inert, because there is no reactive group, resistant to most chemicals except strong oxidizing acid. It absorbs less than 0.01% water. So, absorption is very low, making it ideal for wet environment. So, ultra high molecular weight polyethylene, so its absorbance almost 0 like polypropylene. Self lubricating with poor addition to dissimilar material. So, it is a self lubricating material, poor resistance to high temperature, but excellent to low temperature. So, that is it is actually for high temperature this application we do not use this ultra high molecular weight polyethylene, but at low temperature it retains its strength and all other characteristics very well. So, it is used for low temperature application. It is hard to process conventionally, usually compressed molded. So, we cannot, it is very hard to process it. Now, thermal characteristics of ultra high molecular weight polyethylene fibers. So, it is basically melts at 130 to 138 degree Celsius, slightly above the HDP, high density polyethylene. Not recommended for continuous use above 80 degree Celsius due to thermal degradation and strength loss. So, although it is having a very high strength, but at elevated temperature like 80 to 100 degrees Celsius, this thermal degradation takes place and strength losses are there. So, these fibers stay tough and flexible up to minus 150 degrees Celsius. So, for low temperature application or normal temperature application, these fibers this is excellent fiber, but above below 150 degrees Celsius it becomes brittle. So, normally most of the environmental condition we do not reach to that stage in practical application. Bulk ultra high molecular weight polyethylene is a good insulator, okay. That is a 0.2 to 0.5 watt per meter Kelvin, while gel spun fiber reaches 115 to 60 insulation, okay. That is it increases, that conductivity increases, and ultra drawn nanofibers exceeds 100 watt per meter Kelvin. So, the bulk material like before it is the fiber is formed. So, it is getting insulation is high, but when we form fiber through gel spinning, the insulation reduces, okay, and ultra drawn nanofiber its insulation, its conductivity increases. This fiber has got as a heat of fusion is 80 joule per gram, slightly higher than certain additives. Now, the ultra high molecular weight polyethylene is known for its good mechanical characteristics. So, it has tensile strength from 39 to 48 megapascal, much higher than much higher in oriented form. So, it is a normal in oriented form is it is much higher, and it has got modulus 0.8 to 0.5 to 0.8 gigapascal, and in oriented form it is almost 50 times more than. So, 56.8 gigapascal oriented composite. So, it has elongation at break 350 to 525%. It is a very high elongation at break, showing excellent ductility. So, that is why it can be used for cut protective textile, where it can absorb some that extension, cut and bullet protective textiles also. So, impact strength is very high, okay. So, around 1070 joule per meter, far exceeds HDPE. It is tough, low friction, corrosion resistant, moisture repellent, and cryogenically durable. So, these are the different positive characteristics which actually is actually due to this ultra high molecular weight polyethylene fiber is very good material for protective textile, many protective applications. Now, you can see the application: body armor, ballistic vest, helmets. There we use this ultra high molecular weight polyethylene. Biomedical applications due to their inert nature, rope, slings, mooring cable, fishing nets, use these fibers, sailing because of the lightweight, sailing liner, climbing gear, we use automotive, aerospace and emergency absorption. So, these are the different high end applications where, and apart from this we can use this in protective textiles, we in card protective or slash protective textile we use this ultra high molecular weight polyethylene. There are many other applications are there apart from this, all this we have listed here. Next high performance fiber is the glass fiber, which is widely used in different protective applications. The glass fibers are thin continuous fibers made mostly of silica, like silicon oxide combined with other oxides such as boron, aluminum, calcium, magnesium. So, basically it is silica, but it is combined with other oxides. So, it is amorphous in nature, which is non crystalline, that they structurally giving uniform properties along and across the fiber. So, that is the nature here. We can see the structural characteristics of glass fiber. It is highly amorphous due to an extensive network formed in the chemical structure. So, it has got extensive network, so highly resistant to biological agents, inertness to the oxidizing agent, heat and sunlight under normal condition. So, they are under normal condition they are inert. Susceptible to degradation by strong acid. So, normal condition it these are not affected, but if we use the hot alkali or strong HCl or sulfuric acid, there it can get degraded. It is hydrophobic. Now, as far as thermal characteristics is concerned, it is an excellent insulator with thermal conductivity of 0.03 to 0.05 watt per meter Kelvin. So, it is very insulating, the excellent insulation is there. Glass fibers can withstand high temperature, non-combustible, flame resistant and smoke and toxin free when heated. So, that basically they are when they are heated, they do not generate smoke or toxin. So, that is why it can be used for high temperature application. For high temperature application we can use, we normally use the glass fiber due to its non-combustible in nature and it is a flame resistant. So, low thermal expansion, stable dimensions across a wide temperature. So, they do not expand too much. So, that is why it is a good material for thermal insulation, high temperature thermal insulation. Glass fibers are very commonly used, thermal insulation. The thermal treatment and high glass fibers content enhance the stiffness, modulus and heat deflection temperature. as far as mechanical characteristics is concerned, glass fibers have high tensile strength, typically ranging from 1900 to 3400 megapascal. Young's modulus is 70 to 85 gigapascal, indicating high stiffness. Shear modulus for E glass is 30 to 36 gigapascal. Glass fiber elongates before breaking, with the thinner fibers being more it is bending more before a rupture. Okay. The tensile strength and toughness rise sharply with high strain rate from quasi static to dynamic loading. So, at a high strain rate the tensile strength and toughness increases. The mechanical properties drop at high heat, but stay strong at moderate temperature. So, at high heat the mechanical properties drop. Tensile strength is reduced by surface defects and moisture absorption. That is true for any fibers. So, and in glass fiber, in case of any small surface defects or some porous portion is there. So, in that case the tensile strength drops. Now, coming to the application, areas of application. Renewable energy, where turbine photovoltaic panels are there. So, there we use glass fibers, okay, for turbine blades are there, wind that is this wind energy blade is there, windmill. So, that blades are made of the this glass fiber composites. Construction infrastructure, composite wall, insulating window, roofing panel. So, there in the construction industry we use the glass fiber. Automotive and aerospace, vehicle body, aircraft components. So, where high temperature is due to its high temperature resistance. So, we can use the glass fiber in all these areas. Electrical and thermal insulation. So, for this application, electrical insulator, circuit board, we use glass fiber. Chemical industries, storage tank, pipes and grating. So, that we can use all these fibers, the glass fibers, due to its corrosive protective characteristics. And consumer good, surf boards, hockey sticks, household appliance, mobile phone casing. So, we use the glass fibers. Marine industries, fiberglass protects boats and docks from seawater corrosion. So, as it is insulating, it is highly protected from the sea water, it does not react with the sea water. So, that is why we can use for marine industry and industrial application, car washes and cooling towers, there we can use this glass fiber. And water industry, corrosion resistant water storage tank and containers, that to prevent any corrosion. So, water storage we can use this glass fiber. Next fiber is the stainless steel fiber, and that we will discuss in the next session. Till then, thank you. you.